Hello everyone, good morning. As I started already basic concept of chemistry, so the first period just we completed just introduction about concept of chemistry. In that we have seen importance of chemistry and the properties of matter and their measurements. So after that, in the measurement of physical properties, we have seen 7 basic units. Those are namely length, mass, time, electric current, thermodynamic temperature, amount of substance, and lastly luminous intensity. So like that. So for these we have seen symbols and their SI units. So already this is completed, and also in this topic we have seen some definitions of important terms comes under basic concept of chemistry, namely mass and weight. We have seen the difference between mass and weight. Mass is fixed for any place. If you go for any hillock area or hill area, or you can go anywhere, but mass of a substance or mass of a person, it is a fixed. Whereas what you can say, weight varies. Varies means it changes from place to place. Because of gravity, that weight is not constant. That we have seen this also, and similarly volume also we have seen. Volume is nothing but if you go for space occupied by substance, space occupied by amount of space occupied by a substance is called what you can say volume. So it's a SI unit also we have seen, length into length into length. That length into length into length means length cube. If unit of length is a mass, that is small m, so we can say m cube. That cubic meter also we can say as a SI unit of volume. So after that density we have seen. As you know, density is related to mass and volume. As density is equal to mass divided by volume. So here the unit of density. So how can you say individual units of mass and volume? If you write, that will become what you can say unit of density. The unit of mass is a meter. So whereas its density, is that volume also, mass by volume is a density. So here volume, what you can say, unit is a m cube, whereas the mass unit is a kilogram. Mass unit is a kilogram. That is kg also you can write. Whereas the volume unit is a m cube. So here kilogram divided by m cube means if you bring m cube cubic meter to the numerator, what you will get? Kilogram per cubic meter. Kilogram per cubic meter is the SI unit of what you can say density. This also you have seen. So similarly here temperature also comes under basic concepts. So here there are 3 scales of temperature. So as you have seen, first one is what you can say degree Celsius, and second one is Fahrenheit, degree Fahrenheit, and third one is Kelvin scale temperature. So here these are related from one to another as in the form of 1 degree Fahrenheit, what we say degree Fahrenheit. degree Fahrenheit is equal to degree Celsius plus 32. This is related in this way. So this is a Fahrenheit. So similarly here Kelvin scale and degree Celsius are related. Kelvin scale and related. Kelvin is equal to degree Celsius plus 273. If we add, it will become Kelvin scale. For example, if you want to convert 37 degree Celsius to degree Fahrenheit, how to convert 37 degree? This is asked in model question paper 1, I think. This question is asked conversion of 37 degree Celsius into degree Fahrenheit. This question is asked for 2 marks in model question paper 1. So for this, we have to use this, what you can say, degree Fahrenheit. Fahrenheit is equal to this, what can be used. Here, in case of degree Celsius, we can write 37 degree Celsius. So here, just we made a mistake here, into 9 by 5 is 9 by 5 plus 32. So here, in place of degree Celsius, you can write 37 degree Celsius and into, what you can say, 9 by 5 plus 32. So here, you can write down, this is as you have degree Fahrenheit 37 into 9 by 5. If you simplify 9 by 5, you will get 1.51 5, remaining 4. If you take 0, what will you get? 5 8 40. So this value will get. So here 1.8 plus what will you get? 32. So here, if you multiply these two and add this, what will you get? 66.6. 66.6 you will get roughly plus 32. So here, how much you will get? 66.6 plus 32.0, get 6. I think 8, this will be 9. So nearly it is 98.6 degrees Fahrenheit. Or this value, what we can say, Fahrenheit, degree Fahrenheit for 37 degree Celsius you will get 98.6. This will be the correct answer for this question, 2 mark question. So like that, just you can see these are basic points what you can say have seen in this topic. Next we can go for atomic mass and molecular masses. Atomic mass and molecular masses of a substances, or even you can see for elements also. So we will see this, what you can say, atomic masses and molecular masses. So today, just we will go for atomic masses, atomic mass and molecular mass. So here, let's first we will see atomic mass. As we know, atom is a very smallest particle of an element or matter, you can say. So when the atom is very very small, so its mass cannot be determined directly, because it is so small that its mass cannot be determined directly. That is why, so the mass, atomic mass is always obtained its relative mass. Relative mass means, so we have to compare the mass of one atom of any element to the mass of one atom of other element, another element. So here the another element is taken, the standard element, atom of element is taken is a carbon 12 isotope. Carbon 12 isotope. So this is what you can say, its mass is fixed. So that is why it is what you can say, it is taken as a standard. So here standard mass is taken as a carbon 12 isotope. So we are getting a relative mass. If you obtain atomic mass of any atom of element, always we have to see mass of one atom of carbon 12 isotope. So in that way we can get the definition for atomic mass of what you can say, an atom of element. So that's why here atomic mass of an atom of element is equal to, we are mathematically writing ratio, even you can tell ratio of mass of one atom of element to the 1/12 mass of carbon 12 isotope. Okay, that can be written in mathematical expression also. So here mass of one atom of element, any element, divided by 1/12 the mass of what you can say, 1/12 the mass of an atom of carbon 12 isotope. So we are taking 1/12 the mass of an atom of carbon 12 isotope. If you divide mass of one atom of an element to the 1/12 the mass of an atom of carbon 12 isotope, you will get the atomic mass of an atom of element. So here, for example, so you can go for, so you can take any example, atomic mass of what you can say, hydrogen. For example, atomic mass of hydrogen. So here atomic mass of hydrogen, again here mass of one atom of hydrogen divided by 1/12 the mass of an atom of carbon 12 isotope. So it comes nearly what you can say, mass of hydrogen as a, so if you write 1.67 mass of one atom of 1.67, what you can say, 36 into 10 to the power minus 24 gram. So this is what you can say, mass of one atom of hydrogen. So here similarly, mass of hydrogen atom, it is expressed, mass of it is expressed in AMU. What is AMU? Atomic mass unit. Atomic mass unit. Atomic mass unit. But nowadays the atomic mass unit is changed by simply U. Nowadays, at present, the unit AMU is changed by U, simply U. U is nothing but U is nothing but, so it is unified mass. Unified mass means that is what you can say, atomic mass unit is changed by unified mass. So that unified mass is equivalent to what you can say atomic mass unit. So here what you can say that atomic mass unit was in the earlier days was used. So we can say nowadays that U, simply U is used in place of atomic mass unit. So here examples, still if you want to see examples for what you can say, oxygen also you can see. Another example for atomic mass of oxygen in place of oxygen. So here how much you are getting means. So another example two you can say atomic mass of oxygen. Atomic mass of oxygen. So it will come mass of oxygen. So it is what you can say, atomic number is 8, but its mass is 16. So here you will get so nearly it comes about mass of 1 atom of what you can say, 1 atom of oxygen is equal to 15 points. So round about 995. 15.995 AMU. That is atomic mass unit also you can write. So like that just you can go through here mass of atoms of various elements. So here the mass of hydrogen you can calculate. If you want to calculate mass of hydrogen clearly, mass of hydrogen is equal to, you can write down 1.6736 into 10 to the power minus 24 gram divided by 1 point, what you can say, 66056 into 10 to the power minus 24 gram. So this will come out, this will get cancelled. If you divide 1.6736 to 1.66056, you will get around about 1.0078 atomic mass unit, or this is nearly 1.008, what you can say, atomic mass unit for this hydrogen. So this is what about we have seen atomic masses of elements. Similarly, we have to go for molecular mass. So as we have seen for atomic mass, how atom is a very small and its mass cannot be directly determined. In the similar way, molecular mass also we cannot determine directly. So because mass of molecule is very negligible, small. So in the similar way, how we are defined atomic mass, the similar way we can define molecular mass. So if you want to get molecular mass of a substance or any molecule, so again we can get the ratio of mass of one molecule of a substance to the 1/12 mass of carbon to isotope. But instead of going in that way, even another method can be used here. How means? So in a molecule, suppose in a molecule, for example, H2O is there. It is a molecule, one of the molecule. Similarly, sodium chloride is a molecule. So if you want to get a molecular mass of these substances, so we have to see how many atoms are there. So hydrogen atoms are 2. There are 2 hydrogen atoms and 1, what you can say, oxygen molecule. Atom. Oxygen atom. So like that, 2 hydrogen atoms are there and 1 oxygen atom is there in water molecule. So here, to get molecular mass of water, what we have to do? We have to add atomic masses of hydrogen, 2 hydrogen atoms and 1 oxygen atom. That is called sum of atomic weights of various atoms are present in that molecule. So here, for example, H2O molecule is contains 2 hydrogen and 1 oxygen atom. So in that case, so therefore molecular mass of H2O molecule will be equal to sum of, what you can say, sum of atomic masses of 2 hydrogen atoms and 1 oxygen atom. So here, what you can say, sum of atomic masses of 2 hydrogen atoms. So for 1 hydrogen atom, mass of atomic mass of hydrogen is 1.008. So here there are 2 hydrogen atoms are there. So 1.008 is what you can say, atomic mass of hydrogen, and we have to add here, sum means add. So 1 atom of oxygen is there into 15.9995 means round about you can take 16 also. In place of 15.995 you can take 16 as a round figure. So in that case you get how much? 2 8s are 16. 0 is there, 16 you can get 0 and 2 1s are 2. Plus how much you will get here? So 16 ones are 16. So this 2 plus 16, what you can say? So 18.016, what you can say, gram. So this much is what you can say, molecular mass of water molecule. So this is how the way of getting molecular mass of water molecule. The similar way we can get what you can say molecular mass of NaCl, sodium chloride molecule. So here sodium chloride molecule contains one sodium atom. So similarly, what you can say, molecular mass of sodium, molecular mass of sodium chloride. Sodium chloride. So its formula is NaCl. So to get the molecular mass of sodium chloride molecule, we have to add atomic masses of sodium and chlorine, then we will get what you can say molecular mass of sodium chloride. Atomic mass of sodium atom is equal to how much? 23 point something is a gram Kelvin. Similarly, atomic mass of chlorine atom is equal to chlorine atom is equal to how much you will get? 35.450 gram. Round figure we get. So here, therefore, molecular mass of sodium chloride is equal to sum of what you can say atomic mass of sodium plus atomic mass of what you can say chlorine. So here atomic mass of sodium is 23 plus atomic mass of chlorine is 35.5. So total how much you will get? So 0.5 as it is you can write down. 5 plus 3, 8 and 3 plus 2, 5. So this is a 58.5 grams is what you can say molecular mass of sodium chloride. So in this way we have to calculate what you can say molecular mass. So even you can take every number of examples here. Not only what you can say sodium chloride simple, even you can go for one more example. So molecular mass of glucose you can do. Glucose. So what is the formula of glucose? C12H22OH. So that is what you can say sucrose. But glucose is C6H12O6. So this is the molecular formula of glucose. So here there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So here therefore molecular mass of what you can say glucose is equal to so sum of atomic masses 6 carbon, 12 hydrogen and 6 carbon atoms. So this is equal to 6 are there into 12 is there atomic mass. So how much you get to? Plus 12 hydrogen atoms are there into 1.008 plus 6 oxygens are there. 6 into what you can say carbon oxygen 16. So like that you can write this one. So you get after simplification 12 6 are 72 plus 12 1s are 12 but 6 96 0. So this round figure. So if you go for 1.008 into 12, so how much is it? 12 8s are 96. 96. So here zeros of there 1 0 you can give 12. So like that just you can get 12.096. Or else if you write this one 16 6 will come 96. So if we add all these three, how much you get? This is 72 plus you take simply 12 plus 96. 12.096 is considered as equal to 12.0. So here, how much we get here? 6 plus 2, 8. 8 plus 2, 10. Carry on. 10 plus 1, 11. 11 plus 7, 18. So like that, here, how much gram we get? 180 gram. 180 gram. This 180 gram is what you can say, therefore, molecular mass of glucose, one molecule glucose is equal to 180. Like that, just you can take molecular mass, you can calculate molecular mass. How means atomic masses, if you know. So, how many kinds of atoms are there in that molecule and how many numbers of different kinds of atoms are there, just you have to find out. And we will know the atomic masses of those elements, atoms of elements, and after adding, means after summing those atomic masses, you will get a molecular mass. So after knowing the molecular atomic mass and molecular mass, so one more concept is there, that is a mole concept. We'll see mole concept and molar mass. So here mole concept, as you know, if you go market, you can purchase banana and you are asking banana to a person selling banana. We are asking to purchase banana for how many rupees? A dozen of banana you may give, like that we will ask. So in the term of what unit you use to purchase a banana? Dozen. So dozen is used, the term dozen, that is a unit you can say in market to purchase a banana. In the similar way, in a laboratory, chemistry laboratory, a chemist can weigh chemical substance for the chemical reaction. So weighing that chemical substance using analytical balance, using the term mole. M-O-L-E, mole. Mole is the amount of substance. That can be, there is a unit, mole is a unit of a chemical substance used by a chemist in the laboratory. So, mole is a nothing but the amount of substance that can contain number of Avogadro's molecules or number of Avogadro atoms or number of Avogadro particles. So your Avogadro number is there, no? That is 6.022 into 10 to the power 23. If you want to take it as atoms, you can take it as atoms. If you want to take it as molecules, 6.022 into 10 to the power 23 molecules. Or in general, even you can take 6.022 into 10 to the power 23 particles. Whether it may be atoms or molecules, is generally term, even you can take a particle. So thus, mole is a unit used by mole concept. Mole concept. And molar, what do you say? Mass. So here mole, what you can say is a amount of substance. Mole is nothing but the amount of substance. And what you can say? Mole is the unit used by a chemist. Used by a chemist in the laboratory. So here mole, when you listen this sentence word, so we are saying that it contains a number of Avogadro particles. But here we are defining mole as a, what you can say, amount of substance that contains as many particles as one atom of number of atoms present exactly in carbon-12 isotope. So like that, even you can write a definition of mole is in this way also. Mole is nothing but so amount of definition for mole. Mole is amount of substance. Mole is amount of substance that contains, as many particles as there are in exactly what you can say, carbon 12 gram of carbon 12 iso. So here mole is the amount of substance that contains as many particles as there are in, what you can say, as there are in exactly 12 gram of carbon 12 isotope. This is what you can say definition of mole of a substance. So here even you can say that mole is the amount of substance that contain 6.022 into 10 to the power 23 molecules. If you want to say mole is amount of substance that contain 6.022 into 10 to the power 23 atoms or molecules or simply you can say particles. So like that you can define mole. Mole is nothing but the amount of substance, that is a unit used by a chemist in laboratory to weigh chemical substance for chemical reaction. So he is using mole. Mole means it contains 6.022. So of course we can say, if you go for molar mass, you will get very easily how much that chemist will weigh in the laboratory. Let us go for what you can say molar mass. Molar mass. So here molar mass is nothing but 1 mole of a substance that contains. So here mass of 1 mole of a substance. Molar mass can be defined as definition of this molar mass is that. So you can define in this way the mass of 1 mole of a substance in grams. The mass of 1 mole. The mass of 1 mole of a substance. The mass of 1 mole of a substance, that is in grams. In grams, the mass of 1 mole of a substance in grams is called, what you can say, molar mass. So here mass of a substance, mass of 1 mole of a substance, mass of 1 mole of a substance in grams is called, what you can say, molar mass. For example, so you can go for example, molar mass of H2O means water. H2O means water. Water molecule is 18, what you can say, round figure, 18.0 gram. So here 18.0 gram, what we are writing, this is a molar mass of a water molecule. So similarly here, example 2, you can go for molar mass of, molecular mass also you can write molar mass of NaCl, sodium chloride, is equal to, what you can say, 58.5 gram. Like that, if chemist uses this molar mass in laboratory in terms of mole also. So 1 mole means it's mass of that atom or mass of that molecule, you can say. If molecule is there, we have to take it as a molecular mass. That will becomes 1 mole of that molecule. So if you want to take a diatomic molecule or atom, so we have to consider its sum of atomic masses in that, what you can say, substance. So thus that molar mass or mole concept, so it can be used by what you can say chemist in the laboratory. So next class we'll go for whatever remaining in the what you can say basic concept of chemistry topic.